Cody Larson,
And I'm Evan Sybil.
and today we're going to replace a filament on a Thermo Electron or Finnegan Delta V isotope ratio mass spectrometer. So the general prognosis right now is we know the filament's out, but the way we know the filament is on a few key diagnostics. And so we came in the morning, and then the first thing we saw was this yellow light right here. And that's telling you that there's no emission, so that's your first indicator that the filament's out. But then the other indicators are, with this red button up here, the filament's on. But if you look at both the box and the trap, those values are 0. And the trap collects excess electrons from the filament. And so under normal operating conditions, the trap will read some higher number. But under when it just says 0, generally means the filament's out. So we have a good indication that the filament's out. And so for this video, we're going to go through the steps we use to change the filament. This mass spectrometer has continuous flow. It doesn't have a dual inlet, and so there's only one pump system, and that pump system consists of a rough pump. That rough pump backs the turbo. And so what we're going to do is we're going to turn off the pumps. We're going to close the valves to the continuous flow. We have both a gas bench and a conflow. Conflow goes to the EA, elemental analyzer. So we're going to close these valves. We're going to turn off the pump. We're going to wait. It takes about a few minutes, less than 5 minutes. You'll hear the turbo kind of wind down. It's got this sort of whining sound to it. And then once that's finished, we'll turn off all the electronics and then open it up. So first step, turn off the filament, just get the power out. You can see all the numbers go to 0. Make sure these are closed, just finger tight. You don't have to tighten them too much. And then since we only have continuous flow, we don't have dual inlet, this button down here doesn't do anything, but we're just going to click that. And then you can hear the pump, the rough pump stopped. And then it'll take a few minutes, and then the turbo will wind down. And then after that, we'll come back and show you the next step. So the vacuum is wound down, so it's no longer, the ion source and the flight tube are no longer under vacuum. We've gone through, there's a big red main switch on the back of the mass spectrometer. Turn that off. That kills all the power to the mass spectrometer. And you want to do that not only to protect yourself, it's about 10,000 volts, but you also want to protect the instrument, of course. And so you just basically just kill the power to the whole instrument. We only need 2 tools. We have a 5mm hex wrench, and we're going to use that to loosen these screws here. There's one up here. Go in there and just kind of loosen that one up. And then there's another one down here in the bottom. Loosen that up, like that. And that allows you to open the whole door and expose the ion source flange. And so that's what you're looking at right here. There's a bunch of wiring harnesses. They made it pretty easy, actually. There are a lot of individual wires inside here. There's about 13 that control different parts of the filament tower. But essentially all you have to do is just go through and take that off. Take this harness. Take this harness off. And then take this upper harness here. Take that off. So now you've isolated the electronics from the ion source flange. There are the next thing you need is a socket wrench. This is a 13mm socket wrench, and you just want to loosen the 4 bolts here that hold the flange on. It's really common to over tighten these things, and you shouldn't. There's no reason to. What's ultimately holding the ion source onto the flight tube is the vacuum itself, and this just kind of keeps things in place and keeps it positioned. So they should be relatively loose, and they were, so that's good. So you got to be a little careful here. Get in a different position. You got to loosen them, but understand that eventually this thing's going to fall out. So you got to do a few things at the same time. First 3 are easy. It's the 4th one you want to be careful with. And the ion source is spring loaded on, so it's kind of compressing a spring. And so when you loosen it, it's gonna kind of pop out at you a little bit. So it's at that point that I'm gonna do that, and I'm gonna kind of grab it by the tower and hold it. It just popped. I felt it. Gonna loosen that top support. Take it off like that, and then carefully with both hands, just want to pull it out. And then that's the tower. So this is the ion source and filament. There's a filament that's inside this box here. There's obviously a lot of wiring, and then these are all part of the focusing. And then a separate video we'll go through cleaning everything out. We're not going to do that today. Today we're just going to replace out the filament. And so for the next step, we're going to take it over to the table and then kind of go through the steps to take the old filament out. I'll show you how we verify that the filament is actually bad, and then replace the new filament. Good? Okay, so we got the filament tower on a good work surface, and we got a little bit of a surprise. And I'll tell you what it is. So let's go through the procedure. So with the tower, it's these two prongs right here are the two that hold these two filament wires. And so this piece back here is the filament. It's basically a light bulb. And so there's a little filament that goes across it. Usually what happens when the trap reads 0 and the emission's 0, it's because the filament's been severed, and so there's no emission. And so there's no electrons going across. And so the diagnosis for that would be, you'd come here and with a voltmeter, test for connectivity between these two prongs. And if the filament's not on, or if the filament's broken, we should get an open link. It means that there's nothing going across. And so it was the very first thing I did, is went through, took the voltmeter, put it on the little sound thing, and that tells you it's searching for open links. And so for example, if you were to put these together, you get that sound, it means that you have connectivity. And so my expectation was that when I would touch these two prongs, I wouldn't get any connectivity. I'd have an open link, but instead I'm getting current across it. And so that's telling me that it sure seems like there's a connected filament across it. For example, here's a new filament. They come in these little boxes like this, and you can open them up, and they're basically sitting just like that in there. They have the same kind of metal tails coming off of them. And if we touch those, you get an open link. Or I'm sorry, you get a complete circuit. This is a good filament. So a little confused about what's going on here. I've not seen that before. So we're going to investigate a little bit further. All right, well, we're going to go forward and replace the filament. And so to do that, there's really just two screws on the bottom. These two right here that we're going to loosen up, and that's going to allow these little tails, kind of pigtails, to slide out. And then there's this screw right here that will loosen up, and another one over on this side here that will loosen up. That's going to allow the filament kind of housing to come off the ion source. The other thing we got to deal with is that there's a fixed magnet right up above here, and we're going to have to loosen that as well to make room to pull this thing out. And so you just want to take the orientation of the fixed magnet before you actually take it off, because that matters. So don't force anything, you know, go easy on things, use some backing if you need to. So for example, you can kind of come in here and sort of give some counter resistance so that when you push on this, you're not bending anything, and just loosen that one. You don't have to take it out, just loosen it. And then same thing over here, just putting a little bit of backing pressure. So when I push the screwdriver on it, I don't want to force anything. You don't want to break anything at this point. It's expensive. So just loosen that a little bit. Again, leave the screw in there. This one up here, these can get pretty tight. And so, you know, sometimes that's just what happens. Go in here and just, you don't want to strip things. You want to push in that pretty hard and then loosen that. And this one you're actually going to take off. So you can take that all the way. Don't lose it. Almost lost it. Put that right there. And then the next one is going to be right here. Gonna loosen that up. Take that off, don't lose those. And then, like I said, it's the fixed magnet that you're gonna have to take off. And it's a little tricky working there because that magnet's always gonna kind of grab the screwdriver. Okay, got that loose. And you just wanna differentiate these screws. I'm gonna kind of put it down on the side so maybe it won't fall over. Got that one out. And so there. Took that magnet out. And so now you can kind of see a little bit more inside there. The filament's going to be inside there. All this stuff is loose. And so we can stand it back up. And it's basically just going to find its way out. I'm going to loosen these up a little bit more. Okay, there we go. So we got the filament out. That's good. So we're gonna look one more time because I was a little concerned with the troubleshooting. And when I look at it, it actually looks pretty bad. So it might be right that it still is a filament. But the diagnosis we had is that when I looked at this on here and I put the voltmeter on here, I still got a current across it, and I shouldn't have. And then we've got our new filament shown here. And again, I won't be able to show it under the film, but I can, under the camera, but I can look and I can see that little white wire going across. That's the filament, and it's continuous. It looks really good. So we're just gonna be very careful right now. Take that out, get rid of that. And then the positioning of it, you know, it's just awkward doing this. I hate to say it, but it just is. So you just gotta be willing to give it a shot, but you wanna get it in there, kind of line it up correctly. You need multiple hands, and then you're going to kind of hold it in there and then put that screw in, kind of hope that it gets lined up correctly. And I like to kind of just start that a little bit. You don't have to go full bore yet. Just get that in there. Get this screw, put that in there. Just kind of get it down there. So that's good. That's a good starting point. The one that's always just unnerving to do is to get the pigtail back in. And so we're gonna go in. I don't like doing this. I always hated this. But you're gonna kind of go in there and you're gonna lift it up and then you're gonna kind of bend it in there. There. So that went fine. And then do the same thing with this one. Kind of lift it up and then push it back down in there. Key thing is that none of these wires touch each other. That would not be good. So there is a tendency to over tighten things. There's a lot of vibration in a mass spectrometer. And so you do want to tighten things a bit, but just don't go into this like it's a lug nut on a 18-wheeler. They're not. These are small screws, so be careful. So just get enough resistance and stop. Do that one, and then kind of come around this side. Again, just give a little bit of resistance, something to push against. Tighten it. That's good. Just don't go crazy. Should be good. These here, you know, there's not a lot of options in terms of how to actually set the filament. Some of the older mass spectrometers, they were slots, and so you can adjust things. If you're running hydrogen, you would run it one way, kind of lift it up a little higher. If you're running carbon, you drop it down a little bit. With the Delta V or the Delta V, you don't really get that option, and so you're pretty much just setting it, as far as I'm concerned. I've not noticed any other means of making adjustments. So it's just in there. Again, give it a good snug, but don't go crazy. Okay, so we're good there. And then the next is going to be to put this magnet, and this is always a sort of a pain because it's a magnet, and so it's going to jump around on you a bit. We're going to put things up like that, and we're going to slide it down in there as well as we can. Thank Evan for doing the holding the camera and doing the camera work here. Okay, so that went pretty well. You can see how it's just in there, and so now, see, it's a magnet. It's a pain in the butt. There we go. I'm gonna push down on that. Okay. Don't want to strip anything too, so if it doesn't feel right, stop. This feels pretty good. I'm not getting any resistance. And there we go. Just snug it down. All right, so that's it. Now that's pretty stripped down. All we did is we replaced the filament. We can go back and we can check the connectivity, just like we had for the last one. Clearly that's not the only, that's not the best indicator, but it's a good indicator. If we didn't have any connectivity, then we would know there would be a problem with what we did. You can go through here now and you can check to see that things are grounded or not grounded. You can look visually and just make sure that as you were kind of moving around, none of those wires are touching anything else. That'll cause a grounding and that'll cause you a lot of trouble. You can go through and you can check each one. So for example, if I put this here and that's going to be grounded because these are the heaters, actually, if you want to heat up the source. So that's going to be connected, but I should be able to, that's the heater, so that's fine. That one's beeping. But I should be able to walk through here and not have any of them make a sound when I go through. And you can iterate that. You can touch any one of these and go through. It's pretty educational, to be honest with you, to look through what each wire is connected to. We'll do another video later when we actually clean the source. We're not going to do that today. Jesus Christ. This is the basically the flight tube, the filament side or the source side of the flight tube. There's an O-ring right here. This is Delta V, so they use just a rubber, kind of butyl rubber O-ring. The 253s, the bigger mass spectrometers, have gold O-rings, and so with those, it's kind of one and done. You know, that once they compress, they only compress once. That's not the case with these. They're a little bit cheaper. These don't hold as good of a vacuum. I'm a fan of just, you know, finger grease can be really good. So I like to go through it and just sort of feel it, make sure there's no cracks or anything, obviously, but just kind of like making sure I'm getting rid of all the dust or anything like that. There's always this tendency of like, I need to be super clean, and you have to be clean sometimes. Other times you don't have to worry about it so much, and it's difficult, you know, certainly for the novices. You know, you wipe down everything super carefully. The O-ring, just make sure there's no cracks in it, and if there are, replace it, and then just, you know, get the dust off of it. At this stage, you don't really have to wear gloves and things like that. We're not touching anything inside here anymore. So we want to just replace it exactly like we took it out. And this is nerve-wracking because this thing's expensive. You don't want to break it. You know, this is probably a $20,000, $30,000 part. And there's any number of ways to break any of the ceramic rods in there, and you don't want to find yourself in that situation. So what you want to do is you want to put it in there. There's this pin up on the top, and when you look, you can see the little slot that pin is going to go up against. There's also a little pin down there, and there's a slot right here that's going to go into it. And you just gotta you gotta make sure it's right. And so, you know, put it in there, get the wire out of the position. Okay, I can feel it, it's good. It's always nerve-wracking. This is the most nerve-wracking thing to do. And then you want to go through and just start putting these back in. Definitely hold it while you're doing this because nothing's holding it on right now. And remember, it's spring loaded, so it's definitely pushing back at me. So once you get one in, you know, that's good. I still keep my hand on it. Well, no, I'm not keeping my hand on it, am I? Get the next one. Get that on there. Again, if it feels like you're crossing a thread or anything like that, just stop. No rush. This one up here. Oops. It's kind of hard with that thing. You actually have to do it with your finger so you can push it down into it. Here we go. Nothing's tight yet. Everything's loose. See, it doesn't feel right, so I'm just backing off a little bit. Sometimes you just want to take a deep breath. Just stop. Try this on the other side. It's not that it's hard to get it in there, it's just an awkward position. That's all it really is. There we go. That one felt a little better. Yeah, that one felt good. It's nice to do it with your finger because you can just, you're more sensitive, so you can feel if it's cross-threading or anything like that. Let's go back up here and see if we can get this last one in. Oh yeah, look at that one. Easy. Good stuff. And you want to make sure that it's got sort of a tongue that you want to, or a lip that you're trying to get up and over. So you just keep looking at it and make sure it looks right. If it doesn't look right, stop. Go back. See, this one doesn't look right. There we go. Now it does. Now you can go in with this. So anyone that's changed a tire in a car knows that almost always cars have an odd number of lug nuts. And it's because you want to make a star sort of shape. It's really ridiculous that Thermo went in here and only had 4. It makes no sense to me in the world. Because what you want to do with the star, you can do sort of a star pattern of going back and forth, but you can't make a star when you have 4. And so what you want to do is you want to equally tighten, you know, this, then that, then this, then that, then maybe go back like this, then that, because you want to compress this thing onto it flat. And so I'm a little surprised with Thermo that they chose 4 and not an odd number. So I'm gonna do a little bit there, a little bit there. I'll come back down here, a little bit there. Come back here. And you can tell it's a really short socket wrench we're using, which is good because it's not going to let us get a lot of torque. We don't want to torque this thing. There's no reason. In fact, you can get a worse vacuum by torquing it. So when the vacuum goes on, that's what's going to give it the, going to pull everything together. This is really just holding things on. That's all it's doing. But notice I'm just like giving it like just the smallest of all tighten and then moving on. I'm probably going to stop there. Like I said, you don't want this to go crazy. That one used a little. Okay, let's leave it at that. So then the next step is to go through and connect these. Again, don't force anything. Everything's sensitive. There, to that. Put this in. And then you got the final one up here. It's the kind of thing you forget, and then you go to turn the source on and nothing turns on, and you freak out. And then you open it and you're like, oh, I forgot to connect something. Always happens. The next thing is to double check. I remembered that, I got that, I got that. That's all good. And then we're gonna close the door. Somewhere, oh, here it is. Go through and close these up. I think there's like a kind of a safety feature, interlock sort of thing that won't let you turn the mask back on if it's not closed. Probably a good thing. No reason to be looking in there when things are going well. It's kind of like opening the oven when you're cooking. You don't do that. If you're looking, you ain't cooking. All right. So we're gonna then go around the back of the mass spectrometer, turn the big red main switch to on, and then we're gonna start pumping down and hopefully get some emission on the filament.